WCSS underscore list is equal to null brackets for I in range 1 comma 15. K means is equal to K means underscore clusters is equal to I. K means dot fit. WCSS is dot append dot inertia. So we are building with n underscore clusters 1 to 15. 15 models will be built. N underscore cluster 1 model, N underscore clusters 2 1 model, 3 4 like that, and we are creating the inertia. It's okay, no problem. PLT dot plot 1 comma 15 WCSS list PLT dot X label cluster number PLT dot Y label WCSS PLT dot except customer ID. Append will append to the list. What is WCSS? It's a list, na? Array. It will be added. The values of inertia is variance. Inertia is nothing but variance. The value of variance will be added to the list one by one. So from elbow plot, can we identify? So if you go to elbow plot, you can see there is a point at 6, there is a point at 5 also. 2 points looks like to be the thing, 6, 5. That is not elbow. Elbow is what? Elbow will not be in the top, na? Elbow will be in the here. Elbow plot is what? If it is on the top, it's not called elbow. It has to be in the bottom side. So it will be either 5, this point, or 6. In most of the times, what happens is this is what we face. In real-time data science, we don't get exact point. We will get a series of points. Now here we got 2 points. Sometimes you will get 3 points, 3 clusters or 4 clusters like that. So when you have that scenario, what we generally do is we build a model with that many clusters. Then we'll plot the clusters and see whether there is overlap happening or not. And also calculate something called Silhouette score. Silhouette score is a score which will tell you whether the cluster formation is good or bad. Closer to 1, good. Closer to 0 and negative, bad. So we will be doing the cluster building for both the 5 clusters and then we'll calculate the Silhouette score. The model that has the highest Silhouette score will be the best fit model, and we'll also plot them into clusters to see whether the clustering is distinct or not. So let us build first 5 cluster model, or before that let us discuss score or Silhouette coefficient is a metric used to calculate the goodness of a clustering technique. Its values range from -1 to 1. 1 means clusters are well apart from each other and clearly distinguished. 0 and -1 means wrong cluster formation. Silhouette score or Silhouette coefficient is a metric we use to calculate the goodness of a clustering technique. Its values range from -1 to 1. Closer to 1, clusters are well apart from each other and clearly distinguished. 0 and -1 means wrong cluster formations. Overlapping, wrong observations in wrong clusters, all these things will be coming into picture. So Silhouette score is another method to distinguish whether the clusters are properly formed or not. Cluster 5 model is equal to n underscore clusters is equal to 5. Cluster 5 model is equal to cluster 5 model dot fit Silhouette score x comma cluster 5 model dot labels. We got a Silhouette score of 0.44. Cluster labeling. So what happens is data frame mol data cluster 5 model dot mol data square bracket is equal to cluster 5 model dot mol data dot head. So if you see here, the first observation will fall in cluster 3. The second observation will fall in cluster 2. So this is how the cluster number will be assigned. Which observation or which customer will fall under which cluster. So you can see here clusters 2 and 3. So add the clusters to your data frame. You will know which customer will fall under which cluster. Which customer will be falling under which cluster. So that is what cluster label will tell you. Which customer will fall under which cluster. You can see how many customers are there in which cluster also. So cluster 0, 79 customers are there. Cluster 1, 36 customers. Cluster 2, 23. Cluster 3, 23, cluster 4, 39 customers are there. 5, 0 to 4, na? This is the grouping of the data which is done. Customers are grouped into 5 clusters. Now you can see each clusters, these are centroids for each cluster. Mean, centroid, midpoint, they're all same. No, I have given a name that to tell us that we are building a 5 cluster. See, the elbow plot pointed to 2. Either it is 5 clusters or 6 clusters. So I built a model with 5 clusters. To tell me that that model belongs to 5 clusters, I gave 5 as the identification. Now I'll also build a model with 6 clusters and then check the silhouette score and the cluster formation. Point? Slightly better, huh? Okay. Marginal improvement. But before that, let us see the cluster formation. PLT.scatter. Let us put the column names. Column names are special characters. X square bracket annual income, X square bracket spending score, comma, C is equal to, C map is equal to, in scatter can give only 2, na? And 2 important variables are annual income and spending score. So how is the cluster formation? Any overlaps? There are no overlaps, right? Distinct formations. Now, which is the best cluster? There is only one, na? What is it? That is not a problem. Complete cluster is overlapping, then it's a problem. Which is the best cluster here? Middle one, blue color, huh? Not violet. This is the middle one, right? Acha, for you got violet. Okay, different cluster. Which is the best cluster is this one. High spending score and high annual income. This is the best one, right?
This is also the best one.
No, this is low spending score and low annual income. You have to look for the upper quadrant. Right side upper quadrant is the best option. High annual income and high spending score. Worst is this, orange. Low annual income and low. This is the one, no? Corresponding to higher annuals. It has to be top corner only. So this is the outer range. If you have everything here, what is it? This is good or bad? High? High. And if everything is here, so always the right of this is the linearity, right? So based on that, these are the best customers, right? These are high spending, low income. The orange, these are dangerous. High spending, low income. 6 is what? Between 80 to 100, right? Spending score is between 80 to 100. And income is between 80 to 120. This is age. This is the age, annual income. This is the spending score. These are the dummies. You can ignore the dummies. This is equal to 1. Dummies is equal to 1. Ignore them. Only look at age, what you call annual income, and this is age, annual income and score. So if you are looking like this, cluster 1, 43 years average age means what? Average age is 43. Upper middle age, right? Cluster 1. For cluster 2, now there is a change here. High annual income. High annual income. Then low spend score. He has higher income, but so if you look at cluster 3, so let us say we have to start with 0. 0, cluster 2, young age, 25 years, no? Low annual income, but high, again, upper middle age, low annual income, low spend score. The final cluster C4, which is the one, upper middle age, sorry, not upper, middle age, high annual income. So based on the centroids, these are the categorizations we can see. Only taking 3 variables, age, thing, the other 2 dummies we are ignoring. So if you are looking at colors, C4 is yellow. Violet would be, no, violet would be C2. Blue, dark blue would be first one, C0. This is what color? Red, maroon, huh? I made a mistake here. Orange, both are 2040. Orange. Mistake. This is yellow, no doubt about it. After yellow, you look at this color, maroon, which has high spending score of 80, but annual income of between 20. C1 is maroon. 40-60, 40-60. Blue, okay. Not maroon. 87-17. 26-78. This is orange. So these are the color codings. Build class 6 model and see if there is any change or not. We have done. Rest of the guys build class 6 model. Number of cluster 6. Other people please do it. Cluster 6 model.
Median income and median spend per people.
It's overlapping, yeah. Monday, we will have stats evaluation, online test, and SQL evaluation also. I spoke to the guys. Last class, you have done SQL also, right? No, only stats you have done. No? So Monday, we will have stats, online test.
That doesn't include probability.
Little bit of probability, conditional probability only. Conditional probability only. What we have done through neighbors. So stats will include descriptive statistics, data visualization, hypothesis testing, and little bit of probability. That's all. You will have 30 questions, MCQs online, right? After that, you will have an SQL here in the class only. Everything is in the class only. Monday you have to come to the class. They said it has to be in the class only. So SQL will be there. I'll give you queries to run. Okay, you will run those queries either using Microsoft SQL or MySQL, your choice. Okay, and then most probably Wednesday we will do we have to do Python programming also. So that Tuesday we will practice, and then Wednesday or Thursday we will do that. Okay, so we have to complete these 3 by end of next week. I told them the papers which they have sent from Bombay are not good. They are pen paper based. All those things are not needed. So we will do online. So MySQL or SQL, whichever you are comfortable, you can use that for querying the data. I'll give you the database, and okay, SQL will also be a 2-hour or 3-hour test. 3 hours will be there. I will give you 15 or 10 queries, some basic to advanced queries, joins and all will be there. It will, you can come, if you are prepared, you can complete it in 1 hour or 1.5 hours, no problem. Okay. Then Tuesday we will practice Python programming and all. Wednesday also we'll do that, and Thursday we'll go to Python test. The for loops, conditional loops, like that, whatever we have done, right? Loops and all. Basic Python questions like string, tuples, all those things will be there. Simple Python questions, and then for stats and all, you can just read the Python notebooks which I have sent you. Okay, all the PDF notebooks you have sent, just read them. When to use what hypothesis test, how will you reject the null hypothesis? Okay, then what is a box plot? How do outliers are calculated? What does normal distribution mean? Positive skewness, negative skewness. These things only will be there. MCQ tests will be there. Either 30 or 40 marks I'll put it, and then you'll get the scores. SQL also, we will do it for 100 marks with 10 or 15 queries will be there. Some basic to joins and all will be there. You can do that queries. Huh? SQL and all, SQL you can just do the queries in the class, right? Stats is both one day only we can do. What is it? SQL you can refer to your queries also. Your old notebooks also you can refer. It's an open book thing only. Okay. This one, stats is a closed book online exam because you will not have time to refer and all. Timer will run. But SQL, you can refer to your codes. Whatever codes you have, you can refer to them. So all of you have MySQL, right? Right? All of you have. So you want a practice session for MySQL? You want a practice session for MySQL? So tomorrow day after we will do that? Yes. Tomorrow day after we have class, we will do MySQL practice session then. Right from basics to the advanced joins and all. Okay. So that you will be prepared for your Monday test and all. See, I want all of you, because what happens is now the system has changed. Gradings will come. They are now doing some gradings, T1, T2, T3, and T4. So it's better to have to submit your queries, files, and also to the Bombay team. So it's better to have proper things. Otherwise, if you fall in T3 or T4, you will not get guaranteed placement. T4 means very bad performance. T1, T2, you should be in T1, T2 means you will have guaranteed placement with 6 lakhs or whatever package they are going to give. T3, basic package of 3 lakhs or they will provide interview only. T4, disqualified, not eligible for placement. That is what they are doing now. So I don't know whether they'll implement from your batch, but next batch onwards, it is 100% confirmed. 28 onwards, they are going to do gradings. Okay. So these things, so tomorrow day after we will work on that part, right? All of you have installed MySQL. Anybody needs to install? Just check it's working or not. MySQL Workbench. Anybody needs installation